Rational functions with quadratic factors have been solved, right? Now let's focus on quadratic factor, rational functions where the denominators are such that they are linear factors, but then these linear factors are carrying a power more than one, like 2, 3, 4, 5. So when this one x plus 1 to the power 2 is a repeated factor, because this one alone, x plus 1, this one is a linear factor. But if it carries the whole factor, the whole linear factor carries a power like 2, 2, 3, 4, 5, like 3, or it can be 4, 5, 6. This is a repeated factor, right? So even when you have x, we say that x alone is a linear factor. Then if you have x squared like this one is also become, so if a linear factor which is x is carrying a power, that become a repeated factor, right? That's what I want you to have in mind. So this is a repeated factor, this is a repeated factor, this is also a repeated factor. So s squared alone as a repeated factor is different from s squared plus 1. This is a quadratic factor. This whole thing is a factor, but x alone we said is a linear factor. So if a linear factor carries a power more than 1, then that becomes a repeated factor. X plus 2 is a linear factor, but x plus 2 all to the power, like say 5, becomes a repeated factor. Okay, so now let's see some examples. So if I have 4x plus 3 all over x plus 2 all to the power 3, for example, you see this is a rational function where the denominator is a repeated factor. This one, right? So it's a denominator is having a repeated factor. So what we do is that there is a different approach to how do we equate? We equate this one such way that you distribute the linear factor x plus 2 at the denominator, because at the basic level these ones are linear factors, right? Linear factors have just a constant at the top, right? This one also have a constant at the top here. That will be b x plus 2 again plus c all over s plus 2 again. Why am I writing it 3 times? Because it is repeated 3, but this one is going to be raised to the power 1, this is going to be raised to the power 2, and this is going to be raised to the power 3. So you start from 1. The first one take 1, 2, 3. But 3 is the maximum power that you have here. So you need to also stop at 3. That's what you focus on. So you distribute this repeated factor as denominators, and then on the numerator you keep just a constant at the top. That's the flow. Let's say 2x squared plus x minus 1 all over, let's say x minus 3 all to the power, let me say 4, right? Or let me use 5 to just so what happens is that it's going to be a over x minus 3. This is going to be power 1 plus b all over x minus 3, the same factor, now to the power 2, plus c all over x minus 3 now to the power 3. You do it until you reach power 5, because that's the maximum power here, right? So plus d all over x minus 3 to the power 4 plus e all over x minus 3 all to the power 5. So you do it until you reach that particular power, maximum power. Let me look at another example. We have s squared plus 1, right? S squared plus 1 all over let's say x plus 4 all to the power 2. Let me just make it simple as 2. It's going to be equal to a over x plus 4 plus b over s plus 4 to the power 2, because this one is 1, this one is 2. If this one was to the power 3, then I will have continued and say c over s plus 4 to the power 3. So you have to make sure that you repeat the same factor, but then the powers are 1. You always start from 1 until you reach the maximum power. You'll be distributing, and the numerators are just one constant at the top. If the thing inside the bracket are linear factor, this is a linear factor inside, this is a linear factor inside, this is also a linear factor inside. So we know that linear factors generally carry what? a constant at the top, constant at the top. That's why they are like that. Then what if we don't have a linear factor at the top, inside? So let's say we have something like x minus 5 all over s squared plus 2 all squared, or all to the power 3. You can see that this one, yes, it's a repeated factor in general, but then if you look at inside, right, inside is a quadratic factor that cannot be reduced. So for quadratic factors, we know that the constant that is going to affect only the numerator at the top, because we said for quadratic factors what happened. So we are going to write, so s squared plus 2 here plus s squared plus 2, but here to the power 2 now, this is going to be power 1 plus something over s squared plus 2 to the power 3. You can see 1, 2, 3 here, right? So that's satisfy the bottom. You repeat the same thing, but you just increase the powers under each. But then what is going to be at the top here is not going to be a constant a anymore, because constants only stay with what, linear factors. But here this is a quadratic factor inside the bracket, and we already know that for quadratic factors we handle them differently, right? We put something like ax plus b. So that one, it says this one becomes cx plus d. This one become ex plus f. So the for quadratic factors, their numerators are in this form, in this form, and in this form. That doesn't, and then the repeated factor are the one that just make the powers to increase. Basically, that's the connection of all the concepts that we've done so far. So if you have something like s squared plus 2 all over x minus 3 multiplying x plus 1 all squared. So this particular one, so you can see that there is a linear factor and there is a repeated factor. So for the linear factor, we know that it's going to be s minus 3a, right? A at the top for linear factors. But then this one is a repeated factor. Because of it is repeated factor, we need to distribute that repeated factor power 1 plus something over x plus 1 to the power 2, right? That's for the repeated factor side. So this one alone caters for the repeated factor side. This one is for this single linear factor that we have. But this, the repeated factor is handled like this. After A, we need to go towards B, and we need to go to C. Why are we just choosing B and C for this numerator? Because what is repeating even itself is a linear factor. You know, linear factor just carry only a constant as their numerators. That's what led to that. So that means that if I have something of this sort, let me clean this. If I have something of this sort, s squared plus 1 all over s squared plus 4 all squared. So that will mean that for the sake of repetition, power 1 plus s squared plus 4 power 2. So I've calculated for the bottom ones already, starting from 1, starting to 2, because the maximum power is 2. Now the numerator is not going to be a constant, because what is repeating, the factor inside here is a quadratic factor. And we say for quadratic factor, the numerators come in the form of a, x plus something else like b. We have doing a and b already, so this one is also going to be cx plus d. Yes, this is the simplest form of expression of this quadratic stuff. The rest is about finding the values of a, b, and c, which we are going to do in the practice problem session.